Good afternoon. We will be doing chapter 4, method of deduction, part 13. Here we will be continuing with the exercise based on the 9 rules of inferences and 10 rules based on the rule of replacement. We have already studied the 9 rules of inference. We know those 9 rules: MP, MT, HS, DS, CD, DD, conjunction, simplification, addition. And we have studied the rules based on the rule of replacement. Those are double negation, De Morgan's law, associative law, distributive law, commutative laws, rule of transposition, rule of material implication, rule of material equivalence, rule of exportation, and rule of tautology. Let us continue the exercise. Construct formal proof of validity for the following arguments by using required rules of inference and rules based on the rule of replacement. The given argument is J implies K, L implies M, P implies into bracket J wedge L, P therefore K wedge M. What do you want K wedge M? K wedge M is K is here in the first premise as the consequent and M is in the second premise as the consequent. Both are conditional propositions. We can join them and then we have the antecedent with us, so we can derive the consequence. So now which rule can you apply to 3 and 4? MP. You have the antecedent P implies J wedge L, P therefore J wedge L. 3 and 4 MP. P implies Q, P therefore Q. So P implies J wedge L, P therefore J wedge L. Now here J and L is here. So we first join these two propositions by conjunction. There is only one rule by which you can join, and that is the rule of conjunction. Now we have their antecedents with us, so you can derive their consequence by the rule of CD. P implies Q dot R implies S, P wedge R, therefore Q wedge S. J horseshoe K dot L horseshoe M, J wedge L, therefore K wedge M. Thus we have arrived at the conclusion. Next one, F horseshoe G and I horseshoe K curl G, F dot I wedge H, therefore H. Now suppose you want H, so you should have with you negation of F dot I. Where is F and I? They are the antecedents of the first conditional statement. But then you need to get the negation of those only if you have the negation of the consequence. You have the negation of one consequent G but not the other. So you can add that by the rule of addition. You'll get curl G wedge curl K addition. Once you get the consequence, then you can derive the antecedents by DD rule. Negation of the antecedents, you have got curl F wedge curl I. Now you can change this into dot by De Morgan's law, putting them into the bracket and writing a negative sign outside it. You can see this, if this is given, then you can replace it by this. You will get not into bracket F dot I. Now you have the disjunctive statement and its negation of the first disjunct, so you can arrive at the second disjunct by the rule of DS. Thus, we have arrived at the conclusion. Now we come to the next. Not A implies B dot curl C curl B. A wedge K implies L, L dot curl B. If you want L, you should have A wedge K. How will you get A? Only if you have negation of the consequent, that time you will get the negation of the antecedent. If you have the negation of this, you will get the negation of this. So what will you do to this to get the negation? I will add C addition rule. Now put it into the bracket by De Morgan's law. Curl into bracket, the sign of B changes B, wedge changes into dot, and C will become negative C. Now you have got the negation of the consequent. You can apply the rule of empty and you will get the negation of the antecedent, that is curl A. Now once you have got the negative A, you can transform it into A by double negation. Now you have arrived at A, but we need to have K also. So what will you do? You will add to it K by the rule of addition. Once you have got the antecedent with you, okay, you can derive the consequent by the rule of MP. Get L. Now you need to join L with not B. That is the rule of conjunction. PQ, therefore P and Q. L not B, therefore L dot and not B. 9 and 2 conjunction. Thus we have arrived at the conclusion. Ninth, D implies curly and G implies R, D, R implies S, therefore not S implies not E. Here you can see that we have two conditional propositions. We have the antecedent of the first, but we do not have the consequence. So we can add, we want to derive the consequent, So what you have to do is you have to add to D the other antecedent, that is G, addition rule. Now we have the antecedent, so you can derive the consequence. Curl E wedge R. Now you can transform wedge into horseshoe by implication, actual implication. The sign of the left component changes, wedge changes into horseshoe, and R remains as it is. So now you can see that R and R is common. Antecedent and consequent is common. So now you can apply the rule of HS and you can arrive at E horseshoe S. Now once you have got E horseshoe S, we have to interchange the antecedents and the consequent by negating both of them, and that is the rule of transposition. Thus we have arrived at the conclusion. Okay, what you have to do here is we want T. So what we do is commutative law you can apply. You can get T wedge into bracket curl K dot curl L. First commutation. Now you can distribute disjunction over conjunction. Distributive law and you will get T wedge curl K dot T wedge curl L. L is on the right hand side, so you have to bring it on the left and then simplify. So commutative law again, and you get T wedge curl L dot T wedge curl K. Commutative law. Now you can separate it by simplification. T wedge curl L. Once you get this, again you can commute it and you will get curl L wedge T. Now what you can do is simplify L from the third premise. See your L, simplify this L and use the rule of double negation to get double curl L. Now we have negation of the first disjunct with us. So we can arrive at T, which is the second disjunct, the DS rule. You have arrived at T. Now we want U. You can get U only if you have K horseshoe T. So we don't have K. So what we'll do, we'll add to it curl K. Addition. And then what we'll do is commute it again and transform it into implication by implicative rule, and then what we have to do is apply the rule of MP, this and this, arrive at U. Once you get U, you can join them to T and U by conjunction. Thus, we have arrived at the conclusion. So, in this session, we have completed the chapter. Thank you.